Ladies and gentlemen, please welcome from Apogee, Greg Braille.
My name is Greg Braille. I work for Apogee. My main task today is actually to turn things over to Adam Zwickey from Pivotal. He's going to be talking about cloud-native architecture, some of their experiences with the cloud, and why you might want to consider that as well. And then at the end, we'll have a little bit of a conversation about some of the aspects he brings up. So with no further ado, here's Adam.
Thank you very much, Greg. As he had said, I work for Pivotal. I'm a platform architect. I have the privilege of talking to a lot of our customers about microservices, about taking an API-first approach to exposing capabilities, and essentially the platforms underneath that. And what I'd like to talk about in the next 25 minutes or so, 20 minutes or so, really will kind of build on what you heard in the keynote today about the values of microservices, and I'd like to kind of explain how some of my conversations go with customers as we talk about this. A lot of it actually centers around the platform. So I'll kind of talk a little bit about Cloud Foundry, which is a platform as a service to run applications, but this is definitely not to just simply explain a specific product to you. Now, as I talk to customers, my goal as an architect or a platform architect is to tell them, well, here's why what we have is the best place to run your microservices. I find that very quickly the conversations end up evolving to, well, why do you want to do this in the first place? What is the value of taking this API-first approach, breaking your capabilities up, exposing them, and then also just putting a definition. What the heck are these things? So I'd like to first talk about what is the goals that end up getting teased out. So when we talk about why do they want to move to microservices or APIs, or pick your buzzword that describes it, there's some very common themes that are teased out. You heard most of these at the beginning of the keynote: speed, scale, safety. Adrian Colcroft, who formerly was head of cloud architecture at Netflix, talked about speed winning in the marketplace. So if you're able to beat your competitors in a new way to interact with your customer, a new way to expose some sort of capability, you're going to have a significant competitive advantage. And to be able to do that with a measure of safety and scale when things fail. I'll give you a little bit of an example. Most of us probably have one of these of what we're talking about. I work with a lot of telecommunications companies. As we know, there's a pretty significant event a few weeks ago. A lot of people wanted to get the new device here. This organization had a little bit of a technical hiccup. People couldn't order and purchase these things. But not only did that happen, people couldn't check their eligibility to upgrade. People couldn't check their data usage. It basically cascaded to their whole middleware and brought it down. So the promise of microservices allow you to, when that takes place, not bring down everyone else, but have some isolation around that. Then on the business side, there's this promise of really changing the focus of our investments that are made by the business. Now, these are fairly arbitrary numbers, but you probably have a significant chunk of spend that goes to keeping your lights on. Maybe legacy is not a good word because you are probably still investing in these things and iterating over them. And then you have a bucket of money that you say, well, we'd like to invest in innovation, new ways that we're going to touch our customers, new markets we might enter. And ultimately, what you'd like to do is make a shift of that. And so moving towards a cloud-native approach will allow you to optimize the way you keep the lights on, so to speak, and allow you to focus more of that investment on the innovations, the new things that you like to do in your organization. And the really interesting thing is that we went from 20% to 50% in this example. That increase is not simply 1.5 times more output you're getting from this innovation investment. Because of the speed and because of the efficiencies that Cloud Native can give to you, this innovation is going to give an order of magnitude higher return on that investment that you put from a business perspective. So let's briefly talk now about what these things are. There's absolutely plenty of hype, plenty of unicorns and robo-cats, I forget what they call this guy. But for better or worse, these things are here to stay. And so I'd like to just frame the conversation of what are we actually describing. So I mentioned Adrian before. He has a really good definition that actually Pivotal, we kind of favor this one, describing loosely coupled things that have bounded context or some wrapper around them. Now, Sam Newman, who has a really great book on microservices, talking about building fine-grained systems, says small things that are focused on doing one thing really well. Now, Martin Fowler uses an analogy that we get from the Linux or the Unix world of really smart endpoints, but not really caring how we pipe things between them. And then the last example is from a book called The Pragmatic Programmer, where it described these things as independent, concurrent objects behind well-defined, consistent interfaces. Now, it's really interesting. Look at the date there. So that's dated 2000. I think it actually was published in the end of 99. That's well before the current hype cycle, the current phenom we see with everyone moving towards microservices. So the question is, how is this any different than what any good software engineer should have been doing for the past couple decades? So this act of manufacturing something, some software, you have some good developers that they'll write their code, then they'll use Make or Ant or whatever tool chain they use to produce something, really has some good analogies to the industrial world and the manufacturing world, because essentially we're trying to manufacture something and move it through a life cycle. And this is, the punchline is, this is where it is actually significantly different from how we've always viewed how we build software. Taking into account all the steps of the SDLC, not just the act of making something. And so I'm going to describe some parallels we see of what took place in the industrial world, the manufacturing world, that allows factories to now look like this in 2016. And what are the similar changes we see in how we operate, how we deploy, and how we build software that will make our enterprises or our companies that build manufacture capabilities kind of have a picture like this. So the first one is interchangeable parts. So Eli Whitney in the early 1800s thought he could achieve some significant optimization with interchangeable parts, specifically with the US military. So what he did is he made 10 guns, all using the same parts, pieces, and mechanisms, put them before Congress, disassembled them, put it all in a bag, shook it up, and then very quickly he was able to put it back together because he had a significant amount of standardization with these things versus specific small little artisan things. Now, the next one is the assembly line. Now, you certainly obviously know what this is, but think of what the whole point of what an assembly line was for. It was to put what the worker needs right within his reach, allow him to do his work, and move that on to the next thing. Really cutting out the waste or cutting out the things that are not adding any value to what this person is supposed to be doing. And then lastly, electrification. Now, really interesting if you look at the output that Thomas Edison and the factories that he constructed or designed and ran was able to achieve. So his iron ore factories at the end of the 1800s, early 1900s, were able to produce, or rather process, 20,000 tons of iron ore with 2 shifts of 5 people each working a normal day. Now, this was at a time when most people were shoveling, putting stuff in like rail cars and doing things very manual, and each person was able to process about 5 tons of materials. So we're talking about 10 people that manually could probably do things at a rate of about 50 tons to now 20,000 tons. That is an order of magnitude amount of efficiency. And so all this resulted in mass production. We're able to produce mass amounts of standardized goods, have factories that now look like that picture that you saw before. The goals of this, well, economies of scale, reduce error, reduce waste, increase profits or increase margins. Now that's kind of exactly what we said at that third slide, or that value that we talk about of why doing microservices. So there's some significant parallels we can draw in the technologies and the things that are available to us as enterprises that can get us that same benefit or that same optimization. So obviously microservices can be these little Lego blocks, and thanks, Brian, that's actually a better maybe analogy to use than taking apart guns and putting them back together. But microservices are those interchangeable things that can be swapped in and out, give you significant optimization of how you manufacture and ship something. So the other bits, well, what about the assembly lines and electrification? Well, those little Lego blocks are not enough. You need a completely different paradigm for how you think. As I said before, you move these manufactured goods through your SDLC, ultimately to the point where they're affecting your business, affecting your end users, your customers. So we could say these assembly lines that Mr. Ford created are analogous to pipelines. And the electrification and the orders of magnitude of more output that these factories that were electrified were able to produce are cloud platforms that now we can leverage as we move our work products, as we move our software through the steps of the SDLC. And I didn't really mention the culture bit, but there definitely is a significant piece of culture that goes into cloud native. Having a mindset of aligning developers and operations, marching towards the same goal, incentivizing these people the same ways. And so all those things are the ingredients that go into what we would say is cloud native. And for the next 10 minutes or so, I'd like to talk about the middle two, the pipelines and cloud platforms. Because I think you'll hear quite a bit about APIs and ways to expose capabilities and construct these small microservices throughout the conference today. So the assembly line is a fairly fair analogy that you're moving something through this units of work through these steps. But it does break down a little bit because the systems, the software that we construct today are extremely complex, many moving parts. Each of those parts probably have its own set of steps it has to go through to be produced. So these pipelines, rather than being an assembly line, is really fast choreography. And there's actually a better analogy that depicts what this really looks like. Now, I'm from Charlotte, North Carolina. I'm not a huge race fan, but it really is impressive the orchestrated chaos that goes into a pit stop, because you have about 7 or 8 different people executing about 73 different tasks and doing that in about 8 to 12 seconds. And then they do this 5, 6, 8, 12 times during a race. And if you can do this consistently really quickly, you're going to have a pretty big advantage. So my takeaway or observation of this is you have multiple actors, each performing their task with a very precise precision to it. And if you're able to do that again and again, you're delivering a significant value. Because really the reality is, as we build software systems today, gone are the days where you write some code, test it, you check it in, deploy it, maybe do some integration testing, then press go, and you're in production. We have systems that are much, much more complex. For example, this is the build process for just one of our components within Cloud Foundry platform. And you need something that can describe these dependencies, and allow you to go through this process extremely, extremely fast in a repeatable way, in a consistent way. Now, at Pivotal, we use a product called Concourse to do this. We purpose-built it for our needs. The point is not to say go check out Concourse, which you should, because it's great. The point is that you absolutely need to have fast choreography within the way you build software. So now let's get to what I actually kind of do for a living, is talking about why Cloud Foundry is the best place or best cloud native platform to run your microservices or to run your APIs or to run your buzzword that you're building. The punchline, or the real benefit, the reason why it is the best place, is the contracts and the guarantees it can give you. And by giving you very explicit contracts at each layer, it can ensure cloud portability. I know that was somewhat in the title of this talk about getting on the cloud bus. The key is this allows you to not really have to choose where you're going to run your workloads because of a specific technical reason, but allows you to just make a business decision on where you want to run your software and your systems. And I'll give you an example. So this isn't going to be a deep technical talk, but Cloud Foundry has this component called Bosch within it that we use to deploy and orchestrate all of our software. And it has what's called the cloud provider interface. Basically, how do we talk to a cloud provider like Google, Amazon, or on-premise like vSphere or OpenStack. If you can say, well, we'll use this contract and deploy our software using this tool, we can guarantee you'll run it on any cloud. And if you're running it then on any cloud and using the software to schedule it, well, now anything can be scheduled across a cluster of compute resources. And it's not just about how do I actually deploy stuff and orchestrate stuff. Contracts will pay it upward. It's all about these contracts and the promises they can deliver. So I can deliver a promise to your application that if you abide by these contracts, you can run anywhere. You can also get a guarantee, and when I talk about contracts and promises, I guess you could really say it means you as a developer, or you as a person that's responsible for some component of this distributed system, don't have to spend brain power because you're getting a promise from the layer beneath you that says, don't worry about it, I got you covered. So in addition to provisioning to any cloud, being able to do that on demand elastically, potentially resilience, failover, scaling, all that could be built right into your application, or operational characteristics of how do I monitor this thing, how do I make sure it's healthy, how do I link it to data services. The fact that you have a contract that says if you abide by this, I will ensure that you get this, it allows you to just focus on writing the business value, writing the thing that is going to differentiate what you're trying to create from your competitors or whatever you're trying to do. So this platform itself is actually sets of interchangeable parts. So if I'm able to say I have a cloud platform that I can describe my resources in terms of what we call BOSH or BOSH manifest, I can know I can procure resources from any cloud and create these VMs and run this distributed system there. Within the platform, it also has this model which we call a build pack. Essentially, how do I construct the execution environment that's needed to run my application? So a JVM and an application server or a web server and your scripting language execution environment. If you can say, I'm going to allow my application to abide by these contracts, well, we can then schedule it across the platform, across all these resources and place them in a container. So that really allows you to focus on just your app. So you see the question marks. What is the best way to make your app, your microservice, or your API an interchangeable part? Well, there's many ways to do that. But if you didn't know, Pivotal is also the curators of the Spring Application Development Framework. Probably the most widely used development framework that exists. And so we've created Spring Boot, which is a very opinionated, pre-built way to construct production-grade applications within the Java context, and allows you to really get away from all the boilerplate stuff that you would need to do to get your application up and running and ready to actually deploy for production. So you could have an actually about the size of a tweet, that many characters, an actual application that you could consider production grade. Now, it wouldn't do anything with that many characters, but all of it's built right into the framework. One thing that's included in there is Spring Cloud, which is a set of modules that are really borrowing and reusing things that Netflix has either published or contributed to the open source and the patterns that they've solved as they move to distributed systems in the cloud. Others like Twitter with Zwickey. And so you get common hard problems that you run into within distributed systems solved out of the box. Things like service discovery. How do I create a circuit breaker so you don't have that cascading failure that I mentioned earlier with the iPhone launch? All those built right in the same way, the declarative way that you can use Spring, you get that out of the box. So Spring Boot can be the way you can turn your application into this interchangeable part that kind of can be swapped in and out and moved around. So to conclude my presentation part, I would say anytime you're in a conversation about microservices, about architecture, your answer can always be, it's cloud native all the way down, and you always win the argument. Now, hopefully you get the reference. If not, see me afterwards. But it really is about making your software as interchangeable as possible, really like Lego blocks, as Brian was talking about before. Be able to orchestrate these things in a repeatable way, very rapid way to ensure that the contracts, the promises that you as an API developer have now made to the people consuming your platform, to make sure that doesn't break with pipelines. And then lastly, taking advantage of the modern cloud platforms that are just available to you, to give you economies of scale, to give you on-demand resources that really can be provisioned within seconds, maybe minutes, worst case, and to be able to give ultimate cloud portability to your applications. So hopefully that was a little bit of a benefit to you. You have a better idea of what maybe when people talk about cloud native, what they're referring to. That's kind of our view of it. Now, in reality, this is challenging with some of the legacy systems that we deal with. So one of my colleagues, Matt Stein, actually created a book on how to migrate your existing stuff to some of these patterns that I just described, and actually practical examples about how to do that. So happy to get you a copy of that. See me afterwards in EPUB, or I can see if I can find a physical book. Can definitely help you as you go on that journey. So with that, I think Greg and I might have a little bit more discussion. Happy to take questions on the topic.
Okay, thanks for coming. So I think the main question people probably have with this stuff is well, what's in it for me? Other than I get to use a cool platform like Pivotal Cloud Foundry and I get to type of different commands, I think there's probably more to it than all that.
Yeah, absolutely. I mean, it really is about changing that equation of how you invest in your business. So, I mean,
Right.
It really doesn't matter if you're a Java developer, an ops person that is stamping out virtual machines or making sure these are healthy, or what your role is in the software development lifecycle. Ultimately, everyone wants to deliver more to the business or to the company
Yeah.
that you're working for. So by adopting these approaches, these technologies, these architectures, it allows you to be more responsive and to do just that, to focus your efforts on value-added activity versus doing things that really are solve problems. We have a lot of meetings that we talk about managing operating systems and stamping out VMs these days. No one's ever going to get a raise from your CIO or CEO saying, hey, you just managed that Linux operating system awesome this year.
Great job
yeah,
updating
great
up
job.
OpenSSH. Yeah.
No, but no one hacked into it, well, I guess that's a good thing. But it's just a solved problem and secure that people don't have to worry about.
Yeah.
So by moving up the change, I actually say, so how did I deliver business value, or how did I deliver capabilities quicker? That's ultimately better regardless of what your job is.
So how do we measure that? I mean, do you have examples of customers you've worked with who've been able to sort of show the impact of using this technology?
Yeah, and usually it's measured there's a couple different ways you can measure it. Some customers, and one specific customer I work with quite a bit, measured it in terms of resiliency. So they found that their business was being impacted because their apps just weren't able to scale enough. It took too long. Their capacity planning was a little out of whack. And so they had initiatives to actually, let's measure our mean time to recovery,
Right.
Our outages, how quickly, how can we keep our applications up? So they had some pretty hard metrics of, by moving to a cloud native architecture, we reduce it this much.
Right.
Now that same customer also said we just need to deliver things faster. And they literally found, and actually Comcast has talked quite publicly about this.
Yeah.
So you can go to YouTube or even Pivotal's website and see some of the presentations at the recent Cloud Foundry Summit and Spring One platform, in which they talked about the benefits they got. So the executive director who kind of led this initiative said we went from taking at least weeks to deliver a feature to taking days. And our scaling of our infrastructure used to take us months. Now it happens on demand in seconds. And they can also measure, you can also then measure just the value that you're able to get and how you redirect those savings.
So it's more than just, hey, it's cool, we can release new features all the
absolutely.
time. They were able to show, I think, like how much more revenue they were bringing in, right?
Yeah.
Because they were able to do that more quickly.
Yeah, and there's definitely a measure of, I could do this cheaper.
Right.
So I use Pivotal as an example. So we actually run and manage Cloud Foundry environment where you can come swipe your credit card and run your application.
Yeah.
And we'll host it for you. It's on AWS today. So right now we have about 45,000 applications running on the platform. And I think it's, last time I checked, and it's a few months old, about 250,000 containers. Probably 250,000 to 300,000 actual units of work, think a container. How many people would you guess it takes to run that?
1 million.
Yeah, that's probably, it's a huge number in our traditional enterprises. If you have a company, probably 45,000 applications is a a fair number for.
Yeah, if you have a rule of thumb, I have to have one admin for every 3 boxes, which I've heard people tell me they actually still run the business by. So.
Yeah, so it takes us 6 people. 6 people to run 45,000 applications, and they're actually not all working, right? They go in pairs, and so they rotate. So I would say it's more like 3.5 or 4 for 45,000 applications. So if you think about the people that you can now redirect to innovating or to doing something more value added to your business, because you only have a couple people that actually care about keeping this thing running. I mean, you can tangibly say we saved this much money because it was much more efficient.
So we're saving money on hardware. We're saving money on administration. We're potentially delivering features more quickly, bringing value to the business. What about security? I know I've heard some folks from Pivotal, from the Cloud Foundry world talk about there's some security advantages as well to, not managing individual boxes as little pets.
Yeah, absolutely. So we find that how you view infrastructure, not viewing it as pets that you get your VM, you always keep it healthy, running, and if it gets sick, you bring it back to life.
Right.
But treat it as something that's always disposable. So view your infrastructure as absolutely disposable. Anything gets out of deviation, destroy it, recreate it.
Yeah.
In fact, you can be more secure by doing that more frequently, because if you think of how threats develop and how security breaches take place, typically someone will gain access to something they shouldn't. They kind of percolate a little bit, just watch things, and then eventually kind of infiltrate your environment, your network, or whatever they're doing. What if you said, well, every 10 minutes, I'm going to destroy every single server incrementally and recreate it? We call it repaving. What if you repaved every server in your environment every 10 minutes or 30 minutes or whatever makes sense? How big of a window does intruders now have to get across your network? Really, every 10 minutes, they're going back to level 0. And that's going to simply just give you orders of magnitude more security.
Yeah,
and that's a whole thing we could talk about for hours, but
It'll be fun, but yes.
One of the bits.
Cool. So it sounds like there's a big cultural change then. I mean, as a developer, I don't log into the box anymore and, look at the stack trace or whatever. I'm managing this platform. Do developers, do they have a hard time making that adjustment?
They do to a certain extent, because I'm a developer by trade and have done that in the past. I mean, you want something that you own, you want something that you essentially will bring back to life if it gets sick, and you have something you get your arms around. And so it does take a little bit of time for developers to say this is a different way to view how we do our job. But all it takes is just one team, one significant tier 1 type application to do some of the things I talked about, and all of a sudden everyone's like, holy crap, you ran the billing system. This wasn't like some little web API that is not really important to our business. Every transaction that flows through our company goes through your system, and you just did this, and you had an issue, and you patched that at 3 o'clock in the afternoon and shipped that in one day. Like, holy crap, that is really fast. That does a lot for culture. Once people start to see that value, they're willing to get on the bus. They're willing to make those changes. So I guess that's a long way of saying it. It's very addictive. Once people see that value, they will adopt it very quickly. In almost every deployment customer person that we work with, we see like this hockey stick curve, right? They go from 1 app to 2 apps, all of a sudden it's 20 apps, then 200 apps, and it's not just like incremental growth, it's this hockey stick type curve. And it's all because people embrace that culture.
Cool. So we're just about out of time. If you wanted everyone to remember one thing, what would it be?
I would say it's cloud native all the way down.
Okay, it's all the way down.
No, I would say though viewing cloud native is more than simply microservices. Because that is a hot topic, a hot buzzword.
Yes.
And Paul Moritz used to be the CEO of Pivotal. He's now more chairman of our board. But he talks about this as not being where you compute. So cloud is not where you compute, but it's how you do it, using the approaches that we just talked about.
Awesome. Thank you very much.
Thank you very much.
Yep. Thanks for coming.
On the subway home.